So now we're looking at using explicitly the table method to be able to crash with cost and multiple activities. So in the example here, we've got an activity network below relates to the number of hours taken to set up for a night market. By employing more workers, it's possible to complete some of the activities in a shortened amount of time. However, this increases costs. So as you can imagine, if I need to employ more workers, it's going to cost me per hour to pay them. So the activities can be reduced in time, the maximum amount of time they can be reduced, and the associated costs are shown in this table here. So we can see, despite there being 10 different activities, we can only actually reduce 3 of them, activity B, C, or G. I can reduce B by 2 hours at most, and it would cost me $8 per hour I reduce. So C, I could reduce by 1, 2, or 3 hours at most, $45 per hour, and G for $65. So there's a couple of things we want to look at. Firstly, we want to be able to find what is the shortest time. So the first thing we do is apply all reductions and see what's the best possible new time that we could achieve. The next layer is then to look at the reductions and say, well, did I need to apply all of them? And if there's a choice between 2 activities that would give us the same outcome, which is the most cost effective? So which is the cheapest version? So doing this just using the table method, we don't need to worry about doing a forward and backward scan. What we do need to do, though, is note down all of the possible pathways through the network. So in the table, firstly, I want to note down the pathway that goes A, D, H, I. So A, D, H, I. And how long does that pathway currently take? So that takes 21. Another pathway, B, E, H, J. And again, currently that pathway takes 22 hours. Another possible pathway, B, F, I, J. And that pathway currently takes 24 hours. Again, I could go C, the dummy edge, E, H, J, and that pathway currently takes 21. Now you don't have to write down the dummy edge, but you might want to note it just so you can see, sorry, that should be C, where you went, but you don't have to because it's not an actual activity. The next pathway from the dummy, we could come down F, I, J, and finally across the bottom, C, B, I, J. So noting all of these in the table, and we'll concentrate on the table now. So remember, moving forward, the longest pathway from start to finish is your critical path. So at the moment, our critical path and our minimum completion time is 24 hours. So now we want to do some reductions. So the first step is do everything that's available to us. So we're allowed to reduce B by 2, we're allowed to reduce C by 3, and G by 1. So instead of applying these individually, I'm going to apply all of them. So if we just think about, and that's where maybe highlighting the activities can come in handy to help you organize the information. So wherever you see those particular activities, they're the ones that you are going to reduce. Okay, so that means the first pathway here, ADHI, none of those activities can be reduced, so this time will still take 21 hours. The second pathway, BEHJ, I can take 2 hours off that activity B, which brings the total from 20 down to, 22 down to 20. For the third pathway, again, we have activity B as part of this pathway. So BFIJ will come from 24 minus 2 from B, so down to a length of 22 hours. C, I can reduce by 3 hours. So their pathway CEHJ will come down to 18, so 21 minus 3. The next one, CFIJ, again, just C there, so I can minus 3 off that pathway, brings that total time down to 20. And finally, CGIJ, I can reduce 3 from C plus 1 from G, so a total of 4. So that brings the total time for that pathway down to 15. But again, my longest path, so the longest time there, is my critical path. So the best I can achieve, even if I spend all the money that I have available, so I spent all the money on all the resources, reducing everything, the best time, the best outcome could be to complete the project in 22 hours. So I'm actually only saving 2 hours. What we now need to do is compare our reduced values, so the column here, which is our best reduction, to the original values and see, did I need to adjust to achieve this time of 22? So I'm using 22 as my guide point. So if I look at this first pathway, ADHI, its time, there was no change, but 21 is below 22. So we are going to achieve a time of 22. So how to achieve the max of 22 hours is what we're talking about here. The second pathway was already 22 with no reductions. So I actually don't need any reductions here. I've met our goal without applying any reductions. The third path, well, I had to reduce by 2 for B in order to get from 24 to 22. So I had to do 2 from activity B, and I'll come back and calculate the cost later. But at the moment, I'm identifying I definitely need to do that 2-hour reduction. From the next pathway, CEHJ was already at 21, so it was already below or equal to 22 without any reduction. Okay, so maybe those ticks mean no reduction. This next path here, CFIJ, originally was at 23. Okay, so originally 23, I have to get it to match 22. So I actually need to take 1 off. The only option I have in order to achieve that is off activity C. So I have to reduce activity C by 1 hour. And then our final path, 19, was already below 22, so no change, no reduction. Looking at the 2 things that I identified as having to reduce, so now I can say I'm going to do activity B. So I'm going to reduce activity B by 2 hours, and that will cost me 2 lots of $8. So $16 to achieve that. I also have said I need to reduce activity C by 1 hour. And so that is 1 lot of $45. Oops. So that means overall, it will cost me $61 to achieve the new completion time of 22 hours. So let's just recap what we did there. Same process when we're doing a single reduction. We write out all the pathways. Okay, so step 1, write out our pathway and the current time. Step 2 is then to apply all reductions. Okay, so 1, pathways and time. 2, apply all reductions. Step 3 is then probably the most difficult to articulate. Step 3 is we want to check what reductions are required. And I want you to think about it as if it's your money that you're paying to apply these reductions. All right, so you don't want to waste money. Even though we could have just done B by 2, C by 3, G by 1 and spent all of that money. So what would that be? I'm trying to add in my head. $208, okay, to do all of those reductions, I think. We can achieve the same outcome by just doing what's required. And so therefore we're minimizing that spend. Okay, so it's about, we don't want to waste any of the resource or money. So over the page here, we have the final example in our notes. So this is a past exam question, which is very typical of what you can see in exam 2, where it's leading you through from some quite basic skills again, and then finishing on this concept of reducing with a budget or minimizing the cost. Okay, so we're just going to work through the whole question. So here we have a community centre is being built on a new housing estate. 9 activities have been identified for the project, and the activity network below shows the activities and their completion time in weeks. So first step is, or first part of the question is asking us to determine the minimum time in weeks to complete this project. So in order to get our minimum time, we need to do our forward and backward scan. So often with a question, this is going to be your first step, especially when it is an extended response question in exam 2. You're doing more than one thing with it. And so they'll often start with this completion time or some float times and things like that. So by now we should feel pretty confident that we can whip through doing these pretty quickly without the need for additional explanation. But if you're not sure, make sure when you do go through it that you do check. And so we get an overall completion time of 19 weeks, but let's do our backward scan because we will need it for the remainder of the questions anyway. Do take time. Don't I even make mistakes when I'm doing it quickly, all right, but do take time to stop and think. Remember, you should end up with a 0 back as the latest start time at the start. If you don't, then you have made a calculation error somewhere along the way. And just because we probably will need it, let's put in our critical path, making sure you're following any red number that gives you the value you put in the box when you've got an option. So there we go. So first answer, first question, determine the minimum time to complete this project. We have 19 weeks. The next part of this question then asks to find the float time for activity D. So going back to our graph, float time for activity D. So where D starts, we've got 9 minus 4. So our float time there is 5. Okay, the question now moves on to a slightly different context. So the builders of the community centre are able to speed up the project. some of the activities can be reduced in time at an additional cost. The activities that can be reduced are A, C, E, F, and G. It's important to take note of those, so it's not all. Which of these activities, if reduced in time individually, would not result in an earlier completion time of the project? So remember, any activity reduced in isolation will only have an impact if it was part of the critical path. And so going back to our critical path that we identified, our critical path is B, C, F, H, I. So if we just note that here, so the critical path, B, C, F, H, I. So C will definitely have an impact. F will definitely have an impact, which means that activities A, E, and G, if reduced individually, will not have an earlier completion time. Often you get asked the opposite of that, which ones will. So just be careful. They will, like we have here, bold and underline the not, if it's something that's a little out of the ordinary. So the owner of the estate is prepared to pay an additional cost to achieve the earlier completion. The cost of reducing the time of each activity is $5,000 per week. The maximum reduction time for each one of the 5 activities, A, C, E, F, and G, is 2 weeks. So you can reduce it by 1 or 2 or 0. Determine the minimum time in weeks for the project to be completed now that certain activities can be reduced. So here we don't have to worry about the cost. We're just finding what is the possible outcome. So apply all of the reductions and find what the new completion time could be. Then part E is asking us to find what is the minimum additional cost to achieve that reduced time. Okay, so firstly, find the time. Secondly, find out how much we have to pay to do it. So in order to do that, we're going to write out the pathways. Okay, so our first step is to write out those pathways. And so we'll see how we go fitting it in here. Actually, I'm going to do it underneath, so we'll definitely run out of room. So our path, the time, our reductions, and then we'll work out our cost. Okay, so one path through the graph, A, D, G, I, and the current time there is 14. Another path is B, E, H, I, and that is 16. Finally, B, C, F, H, I, which was our critical path, and we said that was 19. Now thinking about all of those reductions. So the reductions that were possible, A, C, E, F, G, and all of them by 2. So let's highlight anywhere where there's an A, where there's a C, where there's an E, F, and finally G. Okay, so you might just circle them or highlight them. I'm only doing the same colour because they're all worth 2, these reductions. So the first pathway, I've got 2 activities that I can reduce, each by 2. Okay, so I'm applying this full reduction. So that means I can take off 4. So 2 activities. So I can take off 4, which means the new time is 10. Second pathway, I've only got 1 activity. I can take off 2. So my new time comes down to 14. And finally, third pathway, I've got 2 activities again, so I can take off 4. Pathway comes down to 15. Okay, so we had our previous critical path. 15 is now the maximum time when all of those reductions are applied. So that's our new minimum completion time, is 15 weeks. Now, how do we achieve? Okay, so how to achieve 15 weeks. And remember, that is at the minimum cost. Okay, minimum dollars. So, the first pathway was already at 14. So we needed no reduction. Okay, didn't need to do those. The second pathway was at 16. We need to achieve 15. So we have to take 1 week. And our only option there is from activity E. So we've only got 1 activity we're allowed to reduce. For the third pathway, in order to get from 19 to 15, we had to do all 4 of those reductions that we applied. Okay, so we have to take 4 off, which means we're taking 2 from C and 2 from F. So overall, our new minimum completion time is 15 weeks. To achieve that, we had to reduce E by 1 week, C by 2 weeks, and F by 2 weeks. So in total, 5 weeks. And that was going to cost us $5,000 per week. So in total, it cost $25,000 to make that saving of 4 weeks in our project time. Okay, plenty of practice in lots and lots of past papers, and also there's some more questions in the supplement to have a look at too. But please sing out if you do have any questions about the process around crashing, around reductions. And some of the questions can be quite tricky once you start comparing different costs. So I encourage you to seek out some of those challenging questions and ask if you're not sure. Okay, good luck.